Yep, we're live. Hello, good evening, everyone. It's great to have you all here today. We've been doing this hackathon, HackAtom India, which is around developing different technologies on Cosmos. And it's also to support the growing ecosystem in India. We see India is the second largest hub in terms of blockchain developers. With this hackathon, we want to tap into the potential of that ecosystem. Today with us, we have Dennis Pradeep from Tenement, who will be taking a session on Starport. Starport is one of the most advanced tools that Cosmos has built recently, which allows you to spin up your blockchain in a very easy and fast manner. So I'll let your Dennis take over from here and walk you through this webinar today in HackAtom Week. Have a great time.
Thank you. Hey, everyone. So today we will be looking at Starport and building a very simple application for verifying proof of file existence. So let me share my screen. Okay, so hopefully you can see my screen right now. So the application that we will be building is an application where you pass a file and the application finds a hash, writes the hash to the blockchain, and it allows us to list hashes of all the files that we have submitted, as well as delete those hashes if you are the same person who has submitted the hash in the first place. So as I mentioned, we will be using Starport. We go to github.com/tendermint/starport, and at the bottom we can see that there is a link to check out Starport in browser. So we'll do exactly that. And what this does is it opens an editor. You might need to sign in with GitHub, but after that, you will see an IDE with Starport already built. And we can check that it's running. So what the application will do is, as I mentioned, we will have an app that will take a file and it will produce a hash that will be written to the blockchain. So to start with, let's generate an application.
Dennis, just to jump in, participants are not able to see your screen. So if you could share your screen, that would be great. I'll add the screen to the stream. Yep, now it's great.
If I hide.
Yep, now it's great. Yeah,
okay, fine.
You could see.
So yeah, let me step back for a second. First thing I did is I went to github.com/tendermint/starport, and below the image there's a link to open Starport in an in-browser IDE. So if you click the link, you will see an IDE inside your browser. And Starport should already be built and ready to go. So the first thing we do is we generate a new application with Starport app. Let's name this application POE as proof of existence. And it will generate an application for us inside POE directory. So if we go into this directory and run Starport serve, we will see that it will install all the dependencies that we need. Then it will build the application. initialize users, and we're basically ready to start building. So before we do that, let's first take a look at the transaction lifecycle and just generally at the structure of our application. As we can see, that there is an app directory which contains app.go, which is a file that ties everything together. It imports modules, it sets permissions for modules to access data from other modules, and so on. So yeah, as we can see, our application was successfully built. We can check that it's running. Sure enough, it does. So we can see that we have Cosmos, we have Tendermint. We won't be using, we won't be building a user interface today, but it's also available if you want to build a UI on top of your blockchain. So going back to our directory structure, we have app directory, we have CMD with the binaries that will be built. And there's view directory, which is for our front end. And there's X directory with one module inside called POE. So next thing we will do is we will figure out what we need in our application. So the first entity and the only entity that we need is a claim that you have a certain file. And this claim will have one property called proof, which will be a hash of our file. So the way Cosmos applications are built is you first need to generate a couple of files, scaffold files, and Starport will help us do exactly that. So let's use Starport inside our POE directory to create one data type called claim. Starport type, claim, proof, and proof will be a string. So we have generated a data type, and as we can see, the application is automatically rebuilt. And we have a couple of new files. One of them is handler. We have new message called create claim. And we have several other files inside the client and keeper. So the way Cosmos applications are built is you define messages, you define types, and each transaction may contain several messages, right? And these messages are handled by a handler. So in our case, it's only one handler called create claim. So right now we can pretty much use what we have scaffolded. So let's check it out. So we have a binary called POE CLI, which is the main binary that we use to interact with our application. And we have a subcommand tx, and inside there we have another subcommand called POE. And we can see that we have one available command called create claim. And if we use this subcommand, create claim, and say foo, for example, from user one, by default, we have 2 users, which you can check out in config.yaml. One is user one, the second one is user two. We can actually create new users, but we don't need it right now. So we'll use user one to create this transaction. Okay, it tells us that we need at least 2 arguments and received only 1. Let's see what's the problem. So our CLI is defined in a directory called client CLI, and we can go inside and check out tx claim. So this create claim is responsible for the subcommand that we're running, and right now it says that it needs 2 arguments. Let's change that to 1. And again, let's wait for the application to rebuild. Now we should not see this error anymore. Yes, so we can see that transaction that will be submitted, and under proof, we have foo. Let's try it out. Of course, this is not what we want, but we want to try to run it anyway. So our application API is available under localhost 1317. And if we check it out, we will see that there is POE/claim endpoint. So for the endpoint, there is a special directory called REST that defines all the endpoints that we have. So we can see that we have POE claim that is accessible by HTTP GET. So that's exactly what we're doing. You can see that we have a proof foo. We can submit one more just to make sure that it's working properly. And sure enough, we see bar as well. But that's not exactly what we want, right? Because right now what we're doing is we essentially are sending strings to our blockchain, which is fine, but we really want to store hashes of files instead. So let's go back to our CLI and make some changes. So as I mentioned, right now, we're just passing a string as the first argument. Instead, we will we'll first import several packages, crypto for finding hashes, coding hex, and IO util to make sure that we can actually take the file from the file system. So let's remove args proof because we will rewrite it. So first we use hasher, which will create a hash for us. Then we read a file as the first argument. Now we're writing the file to the hasher to create a hash. And finally, our args proof, which will be the value that we will write to the blockchain, will be the hash of the file. So hopefully there were no mistakes. Let's see if it builds. So if we go back to our API and refresh the page, we can see that initially it hasn't generated a block, but if we refresh one more time, we'll see that there are no results. So it has built successfully. Now we're going back to our CLI, and instead of passing a string, we will actually pass a file. So let's say we'll pass a README file. So right now we can see that instead of just a string, it generated the hash of this file for us. And let's say the first characters are C4F9. Let's cancel that and try again just to make sure that it's actually a hash instead of just a random string. Yeah, it is a hash, same string exactly. And let's submit it and check that it's running. Okay, cool. So this is a very basic example where we find a hash of a file to prove that indeed at this height we had access to this file and we could generate a hash from it. So let's add one feature to this application, and that is to delete our claim.
just to sorry to jump in. Can you please increase your font size so everybody could see? I mean, a
Yeah,
lot of people
yeah,
have their GitHub repo open, but still, if you could increase the font size, it will be really helpful for everybody to look the actions.
Is that better?
Yep, still better. Great. Thank you so much for that.
Okay, cool. Okay, now we'll add one more feature to our application, is actually to delete a hash that we submitted. And we will delete a hash only if the person that submits the transaction is actually the same person that submitted the hash in the first place. So only the owner can delete the data. So the way messages, the way features are added to Cosmos as Cosmos modules is, first of all, well, that's at least the way I prefer to do it, is you start from messages. So a message, in our case, we can actually copy an existing scaffolded message, which is for create claim, and just replace some strings in it to make it delete instead of create. So create a new file called message delete claim, paste, we'll basically create a copy of this file and replace create claim every instance of create claim with delete claim. And the reason why we can do this is because the message will contain exactly the same fields. So it will contain ID, creator, and proof. So let's replace every instance of create claim with delete claim. Now, to make our message available to our application, we need to register the message inside codec.go file. So we copy register concrete, and instead create, we'll type delete. Now, the next step is, after we created a message for delete claim, we need to handle this message. And handling happens, well, inside a handler. So right now we have a handler called message create claim, and we need to create one for deletion. So we create a new file. And inside this file, it is in the package called POE. We'll import. First of all, we need to import types of Cosmos SDK. Then we need to import a keeper. A keeper is part of your application that is responsible for writing data to a store, which is an abstraction over persistent storage. So we'll use keeper from our module, which is located in Tendermint. Well, you can name it any way you want, but we've named it Tendermint, POE, X POE, and keeper, which is this directory. And we also need to import types, which contains our message. Just copy it from here. So now we need to create a handler function. Handle message delete claim. takes several arguments. One is context, which includes some meta information about the message, the request. We are using a keeper, which has all the functions to write data. The message itself, which is of type message delete claim, which we've just created in our types package. And it will return SDK result. It can also return error. But okay, so what we will submit as our delete claim message is a claim of type claim. And it will have the same fields as create claim message, which is a creator. It's the person or entity that submitted the message. ID, which is just a unique ID generated to differentiate between different objects, starter system, and actual proof, which is a hash of the file. Now what we need to do is we need to get the claim first before we can delete it, to check that the creator of this claim is actually the person that submitted the message in the first place. So we will take our keeper and call getClaim function. We don't have this function yet. We'll implement it next. But what it will do is it will return claim, and now we need to check that the claim creator equals to the creator in our the creator from our claim is the same as the creator that submitted the message. And if it is, then we can safely delete claim because we've checked that it's the same person. If not, it will return an SDK error. Okay, so that should do it for the handler. And now we can see that we didn't implement two functions inside our keeper. So let's do that. We go inside our keeper. We actually have two functions already defined, which one creates a claim and one lists claim, which is called when we actually call our endpoint, HTTP endpoint. And now we need to create two more functions. One will get the claim, so it will take a context as well. And we also need claim from our types. We've already have this type defined since we've scaffolded claim type. You can see it here. It's very simple struct. Okay, going back to our keeper. And it returns a claim or an error. Okay, the way we do it, the way we return a claim is we first need a store, which we can take from our context. Then we need to find the claim by proof. So the way store works in Cosmos SDK is it's basically a large key value store ordered by key. And keys are strings and values can be anything you want. So what we do is we find our key. Claim prefix. So basically every key for convenience has a prefix that is the same as the type of the object. So in our case, that would be claim, and then it will have a hash. So our key will be claim prefix, which is claim dash, and the proof of the file. The hash of the file. So we get our entity, we get our object using a function called get by the byte key, and we put it inside claim. So if there are no errors, we return the claim. Okay, that should take care of getting our claim, except I think I made a couple of mistakes. Yeah, store key, on Marshall binary, length, prefix. Yeah, hold on a second. Yeah, 2 L's. And now we implement a very simple delete claim function. I'll take the function signature just so I don't make any mistakes. And what it does is it takes our, again, store from the context, basically the same in every function. We take our key, and we simply delete the object by key. Okay, now we shouldn't have any errors in our handler because we've defined all the functions. Now, what we need to do first, let's check. We have delete claim in our codec.go. We need to register our command that we have created. Oh, we actually haven't created the command. Let's create the command as well. So we need to create a command that will delete the claim. Essentially, it looks the same, pretty much the same as create claim, except we don't need to pass the file. We just need to pass a string, which should be equal to the claim that we want to delete. I'll just paste in the function. So what it does is it creates a subcommand called delete claim, which accepts one argument as proof. And it passes this argument to our handler, which then calls the keeper method to delete the claim if the creator is the same. Okay, now again, store key. Now the only thing that's left is right now we actually have a we haven't registered the command that we've written, right? We've defined. So in client CLI tx.go, we actually need to register delete claim subcommand. Let's check that everything is correct. cmd delete claim. Okay, it says, hold on a second, undefined. Get cmd delete claim. Okay. Let's try running our application and see what it. Undefined get cmd delete claim. Okay, let's debug that. So we have defined delete claim command. That should be correct. Create claim. Okay, interesting. He did made a mistake. Let's. Okay, now it actually doesn't like that we haven't registered our handler, which we forgot to do. So we've created a file for the handler, but we forgot to actually register it. Let's do that. Okay, let's check our errors. Okay, we have a mistake in our import. We forgot to specify that it should be imported as SDK. Now it should be building correctly. Let's try running POE CLI tx POE. We have create claim, but we don't have delete claim. Let's fix that. Inside tx, we need to import, not import, but register get cmd delete claim. Comma. Okay, it seems to be building correctly. Let's check that our command is now available. And yeah, we see that we have a delete claim command. So let's try it out again. We don't have anything on our blockchain. And let's use create claim command to create a hash of the README file. It's the same as it was before, of course, since it's the same file, it hasn't changed. So we can see that it was successfully written. And now let's copy the proof. And let's use delete claim method, and it accepts one argument, which is a proof. And from, let's say, user 2, and as we can see, it doesn't delete our object because it's not the same user. Now let's try deleting with the same user as we have created. I mean, the same user that has submitted the hash in the first place. Okay, it still doesn't delete. And I think I know the reason why. So sometimes there are bugs that are kind of tricky to catch. It doesn't show any kind of error. But I think the problem is that we haven't modified the keeper. So our scaffold generated a create claim command, create claim function that is responsible for writing data to our blockchain. And the way it works is it takes a claim prefix, which is string claim dash, and adds claim ID. So right now, the way our data is written, even though we don't see it in on our endpoint, it's actually claim dash, then a unique claim ID. Whereas when we delete our claim, we search for proof, so it simply can't find the same object. So instead of writing it with proof, we need to instead of using ID inside our key, let's use proof. When we save, it automatically rebuilds our application. So after rebuilding every time, the state gets reset so that we don't have any kind of inconsistencies in our blockchain. And let's submit the same command from user 1. Now let's try deleting. This claim from user 2. It should fail. Yep, it doesn't delete. Now let's delete from user 1. So the proof should be the same since we've submitted the same file. And as you can see, it successfully deletes the claim, and only if the address of, the creator was the same. The person that submits delete claim is the same as the person who submitted create claim. So we've implemented a very simple application that keeps track of proof in a form of file hashes. So it lets you prove that you indeed had the file and you created a hash of this file, and as an owner you can actually delete it. So Cosmos SDK, of course, allows you to build an application on top of that using an API. So right now we're just using a CLI, but of course, since you have HTTP endpoints, you can use it to build applications. Starport, for example, by default scaffolds an application that you can extend that looks something like this. It uses Vue.js, and you can sign in with a mnemonic that is provided every time you save your application. It gets rebuilt So you can submit claims, but the UI here expects a string, since it doesn't know that we have modified our application to actually accept files and create hashes. So that can be an interesting challenge, to modify the application to actually accept a file, create a hash in JavaScript, and submit it to the blockchain. So it would mirror the same features that we have seen in the CLI. So just to recap, the way you would implement and add features to your application is first of all, you need to scaffold a basic application, and Starport CLI can actually help you with that. So you can read the README, you can install it on your machine with NPM or Homebrew, or you can try it out inside a browser, as we did right now. And then you can scaffold an application, you can serve it in development mode. You can create data types, which we did for claim, right? We scaffolded claim data type with one field called proof, and you can have multiple fields. And by default, it will scaffold create entity function for you. And the way you add features to your application is you first define a message, and inside a message, you have all the properties that describe what kind of state transition you want to see after this message is handled. Then you create types if you need other types than you already have. Then you define handlers that take a message as an argument, and handlers have logic that basically, for example, allows you to call keeper methods if some condition is met. For example, in this case, if the user is the same, right? Or it can be like if the height of the blockchain is more than something, or any kind of condition you need in your application. And then handlers call keeper methods. So it's very similar if you are new to blockchain. It's very similar to web development, where you have HTTP requests and you handle them with handler functions. Same here, but instead of HTTP requests, you get messages. And these messages can be generated either from HTTP requests in case when you send transactions from your browser, for example, or you can create a CLI. So inside the client directory, you have a CLI, which helps you to create commands, right? And you also have REST directory, which contains all the endpoints that you need for your application, so that you can easily build front end in JavaScript, for example. So by default, Starport, as I mentioned, generates a front end application that you can use as a template to help you create your own. It uses Cosm.js library, and if you go into view src store index, you can see all the methods that the scaffolded application uses to initialize the application, fetch chain ID, sign into your account with a mnemonic that is printed into terminal. And it allows you to submit entities and update accounts. So you can use this as a baseline to build a more complex application. So yeah, that's pretty much it. One last thing, I guess, is with Starport, it's pretty easy to configure your blockchain. For example, add new accounts, change name of your accounts, add new tokens, like let's say you want 200 foo. And also if you're more adventurous, you can change the Genesis parameter, for example, chain ID, my chain, and also other parameters. It's basically the same as if you were to edit the Genesis file manually, but it applies the changes after each refresh. So yeah, this is the basic introduction to building applications with Cosmos. Hope that was useful. I think right now I'm ready
Thank you.
for questions.
Thank you so much for helping out with this introduction for Starport. There are a few questions from the community. I'll just list them down here so that you could see. And it's so one of the questions is here. I presented on the screen. It's from Cherish. Cherish, if you could answer that. What are the possible repercussions of deleting the delete claim function
For a fintech enterprise perspective? That's actually quite a question. Well, this application is obviously not meant to be used in production. This is a very simple application that just lets you understand how to submit values to your blockchain, in this case, hashes of files, and delete based on a very simple condition, which is you are the same person that submits the proof. So yeah, it's hard to answer this question, like what are the repercussions. Basically, this is a demo application, so I would advise against using this for any production purposes. So you would have a lot more logic, and that really depends on what you're trying to achieve. Yeah.
In case of Dennis, if they're using Starport to create a fintech production level application, is that possible?
Yeah, absolutely. Starport uses Cosmos SDK, right? So Starport essentially provides a couple of very useful features on top of Cosmos SDK. First, it lets you scaffold an application, right? So with one command, you get a blockchain running with tokens that you can then run with one more command, right? And Starport Serve will build your application. It will initialize it, and it will actually watch for file changes. And if you save a file, it will rebuild. So it's very useful because otherwise, what you would have to do is after every change, you would have to manually delete the data directory because it might be not up to date, right? Your blockchain will just not be able to replay to the same values, right? And you would have to initialize it, build it, and run it manually, and that's pretty much handled automatically. And it allows you to scaffold types. So after you've scaffolded your application, you pretty much can do anything you want. You can like build a production-ready application, but of course, if you are planning on launching it, you would not use Starport Serve, but you would instead use your app D, then start command to start your node, and app CLI REST server to start an API. So for more information on that, you would actually have to read Cosmos SDK documentation. But yeah, the short answer is yes, of course, you can build production-ready applications with Starport. It just allows you to get up and running in minutes as opposed to like hours or days if you were to do it manually.
Sure, sounds great. Thank you so much, Dennis, for answering that. If you guys have any other questions, if you want to know more about how you could leverage Cosmos SDK to build production grade applications or something that you're trying to build in HackAtom India, please let us know. We could help you out. And of course, there are many useful implementations that can be done using Starport. So maybe you're just getting started and there's a certain functionalities that you're thinking of initiating that you could share or you could ask about it. And I'm sure that there's certain modules that you could spin up very quickly using Starport. Then it's just for better understanding of the crowd, since a lot of people here are coming to Cosmos ecosystem for the first time, right? So according to you, what are some of the simplest use cases that can be developed using Starport? Say, for example, can a DeFi a DeFi application can be built, and what sort of modules or functions from the Starport can be used to lay down the foundation for that application?
So the goal with Starport was to actually keep the minimal number of modules so that it's easier to navigate, as opposed to just cloning a bigger application such as Gaia, for example. So with Starport, you can, with one command, add CosmWasm, for example. So you would be able to run smart contracts. So I would probably look into projects such as Kava that have more financially oriented modules. From the SDK itself, there are a number of default modules that you can look into inside github.com/cosmos/cosmos_sdk/x. It's a directory for the modules that you can use. Specifically for DeFi, I would probably say look into how Kava implements certain modules. That's a good example. Or if there are any good examples written in Rust for CosmWasm, that would be a good place to start as well. I think CosmWasm has a directory of example contracts as well. Some of them are related to finance, I think.
Absolutely. Thank you so much, Dennis, on that. For a lot of people who joined us today for the first time, yesterday we hosted an workshop with CosmWasm, and we would be sharing that video with the community today. And then you could get a lot of ideas what sort of modules that you could leverage, and over it, how you could use Starport to integrate CosmWasm into your application, whatever you're building. So these are a couple of things. I'm happy to wait for a couple of minutes, and then if you guys have any questions, happy to answer that. Otherwise, we can wrap up this session and meet tomorrow for another session that is with Ethermint team, which is an additional feature of Cosmos SDK that you could leverage to connect or use functionalities of Ethereum on Cosmos SDK.
Of course, you can reach us on Discord. We have a channel called Starport. So if you have any questions, feel free to reach out, and we'll try our best to answer any questions or create issues on GitHub, whatever is easier.
Sure. I guess that as there are no questions at the moment, which we would encourage everybody to join the Discord channel and also route a lot of queries that we receive on these channels so that we could receive the answers for the community. at the end, thank you so much, Dennis, for joining us today for this session. Really enjoyed it. It was very well structured in form of the presentation, and also it's great to see how Starport is taking shape, and would be great to see the implementations using Starport in the HackAtom India. So,
thank you for inviting me.
Absolutely.
Have a great
good day.
hackathon.
Yeah, thank you so much. I guess everyone is building great things. What we have received so far, the feedback, and happy building, everyone. Hope to see good projects coming out of HackAtom India.
Goodbye.
Goodbye, Dennis. Thank you, everyone, for joining us. You all guys can join Cosmos Discord channel. All the resources are available on cosmos.network. Also, you guys can join Cosmos India Telegram channel. You just need to go to Telegram and find Cosmos India. We are happy to help the community both on Cosmos Discord channel, where you could find a lot of developers, and as well as on our Telegram group if you have any general queries. And if you're still waiting for to join in HackAtom India, now is a great time, because we're doing HackAtom Week, where we are inviting different people from the Cosmos ecosystem to take these sessions. And soon after that, we would be jumping into supporting as many questions or doubts you would have on while building the project. So it's a great time. Start now. There are a lot of bounties. You have opportunity to win 10,000 USD dollars for in this event. Wishing you all the best, and see you tomorrow.